Hey GPT, can you ask me some of the Python questions so I can practice my English and also my Python concept?
Absolutely. I'd love to help with that. Let's do a mix of both concept based and practical coding questions. So, first up, can you explain what a list comprehension is in Python and maybe give a simple example? Then we can move on to something like writing a function to reverse a string. How does that sound?
Yeah, I can easily tell you like what is a list comprehension. It's a a kind of a quick way to make a list like in single line of code. You can make your perform your operation like using for loop, and you can square you can square the numbers in one line of code.
Yeah, exactly. That's a great explanation. So, for example, if you have a list of numbers, you can write something like x squared for x in numbers, and that will give you a list of their squares all in one line. Now, do you want to try writing a function to reverse a string like we talked about? I can help guide you if you need.
Can you ask me two more questions?
Of course. Let me give you two more. First, can you explain the difference between a shallow copy and a deep copy in Python? And second, can you write a Python function that checks if a given string is a palindrome, meaning it reads the same forward and back?
That's the like topic I always just take like what is a shallow copy and deep copy. Can you explain in a simple way like I can understand it? I don't know what is a shallow and deep copy. I have seen like many times this concept, but I have like never tried to understand. But now when I always come to you, you always ask me these questions like shallow copy and deep copy, and I ignore this question. But now you are again asking this question, so I want to know that what is actually this is. Can you explain what is a shallow copy and deep copy?
Absolutely. So think of it like this: when you make a shallow copy of a list or an object, you're creating a new reference to the same underlying data. So if you change something in that shallow copy, it also changes in the original. A deep copy, on the other hand, creates a completely independent copy. It's like starting fresh. So changes in the new one don't affect the original at all. If you want, I can give you a small code example to show the difference.
Yeah, can you give me this some example, like basic example of both the things, so I can able to understand it?
Of course. So let's say we have a simple list. Imagine we have a list called original. If we make a shallow copy of this using something like shallow copy's original copy, both lists still point to the same nested objects. So if we do something like shallow copy 0 is 99, it changes the original list as well. But if we make a deep copy using the copy deep copy function, then the two lists are completely separate. Changing one will not change the other.
Okay,
Does
okay.
that example?
Can you please stop and can you ask me another question? Except this, I will study this shallow and deep copy further. Later, I will study. Can like ask me some other question?
Yeah, absolutely. No problem at all. Let's switch gears. How about this? Can you explain what a decorator is in Python and give an example of how you might use one?
Yeah, like a decorator is a kind of function in Python that adds some extra activities and extra behavior to original function without changing it.
Exactly. That's a great summary. So, for instance, you could have a decorator that logs when a function is called or measures how long it takes to run, and you apply it by using the at decorator name syntax above your function. If you want, we can try writing a simple decorator together.
Like we have some kind of a wrapper, and you are just running something like so before the main function, and then you are also running after your main function. So this is a kind of two things is like running before and after the main function, and this thing is actually kind of a concept of a decorator.
Yes, exactly. That's a perfect way to think about it. The decorator wraps your original function, letting you run extra code before or after, or even modify the result. If you like, I can show you a basic example of a decorator that prints a message before and after your function runs. Just let me know.
Okay, can you ask me some one more question?
Of course. Let me ask you one more. Could you explain what a lambda function is in Python and give an example of when you might use it?
I can explain you what is the lambda function. So lambda function is a kind of a anonymous function. It is a kind of a small function. It does not have a name. It has a expression and argument.
Exactly. Yeah, that's right. So a lambda is basically a small one-line function defined with the lambda keyword. You often use it for simple operations like in sorting, mapping, or filtering. For example, you could say something like lambda x is equal to x times 2 to double a number. Great job.
Okay, can you ask me one more question?
Of course. Here's another one. Can you explain what the difference is between the arcs and quarks parameters in a function and when you would use each of them?
Yeah, I can explain like arcs and quarks. It basically takes the values. Like quarks takes values, like it returns the values in key value pairs, and it takes value in key value, and it basically returns a kind of a dictionary. And where arcs can take multiple values, like kind of a tuple, and then you can give the lots of number to the arcs, and then you can also find the sum and multiplication of all the numbers inside args. So args takes values like normal values 1 2 3 4, and in the quarks it takes the value like using key and value.
Yeah, that's a really solid explanation. So, just to add, args lets you pass a variable number of positional arguments, and quarks lets you pass a variable number of keyword arguments. And they're super handy when you want to keep your functions flexible. Awesome job.
Okay, so thanks for asking me this question, and I will be studying now one like concept which is shallow and deep copy, and after finish it I will come again to practice some Python question with you. Thank you.
You're very welcome. I'm really glad you found it helpful. Take your time with the shallow and deep copy concepts, and whenever you're ready, just come back and we'll dive into more practice. Good luck with your studying.